In this chapter we are going to take a look very briefly at KNX RF. So what is the KNX RF? KNX RF allows the wireless transmission of telegrams or packet of data by means of the medium radio frequency. It is therefore not required to install a separate bus cable, so you don't need to install the green cable of KNX. Then KNX RF is in fact very interesting if an existing TP installation has to be extended and no additional cables can be installed due to local building regulation. Okay, so where it is used to extend the TP installation where you cannot do the wiring again, so you use the KNX RF to extend your system. In order to guarantee the correct functioning of KNX RF system, the basic of the RF medium and especially the structure of KNX RF will be related in this chapter. So we take a look at the fundamental of radio frequency transmission in KNX. Okay, first of all we talk about the RF transmission medium. The range of the KNX RF components is indicated as a free field range. The free field range is significantly higher than the achievable distance within a building. Due to the maximum allowed transmission power and the limitation of available energy for the transmission in case of battery operated or battery free devices, the free field range is limited to approximately 100 meters. So free field range for KNX RF is 100 meter. So, and the radio frequency signals are attenuated on their way from the transmitter to the receiver by many factors. So it means it is affected by the disturbances. The real operating range within the building is therefore reduced. KNX RF use 868 megahertz. Okay, 868 megahertz frequency band, and you know, for using the smart home, I mean the devices in a smart home around the world, these type of frequencies differ. For example, it's in US it's 920, in China it's 433 megahertz. So it really differ country by country, but this 868 is follow the Europe regulations. The next point is the reflection that is happening in transmission maybe provide the positive reflection, so signal amplified by the reflection, and may provide us the negative reflection. It means signal reversed by the reflections. The next important point is interfering factors due to the structural or other special conditions must be taken into account during the building planning stage. The mounting site for the KNX RF devices must therefore be carefully selected. Under these considerations, if the installation site cannot be freely selected, a good radio connection is achieved in most cases by using KNX RF repeater. So if you think or evaluate your project that maybe you lost the data during the transmission, so you should use the repeater. The repeater is going to amplify these transmission signals. In the case of main operated KNX radio devices, it must be ensured that the main voltage is available at the selected mounting site. The next important thing is transmission technology in KNX RF is based on a single channel solution or multi-channel solution. So first we talk about single channel solution. First of all, you can look at the block diagram of the KNX radio transmission. So the information signal is coming to the transmitter at the modulator side, then it's go to the output stage. Okay, so it's translated to the wireless. So from the wireless, from the antenna to the antenna of the receiver, it's going to be transmitted in a wireless way. Then in a receiver, it is received in by the antenna, and it's amplified. And then the part named demulator, it's going to decode the signal to the 0 and 1 as an information signal. Okay, great. So in radio technology, the information to be transmitted is modulated on a carrier. This can be either the amplitude, the frequency, the phase angle, or combination of these manners. This modulated carrier is transmitted to the RF receiver, and the received signal is demulated. The information is recovered from the signal, as I told you in a block diagram. Okay, great. So in the KNX RF system, the frequency modulation or frequency shift key is used as a modulation process. The logic state 0 and 1 are generated by a slight deviation in the carrier frequency, also called middle frequency. In KNX RF system, 868 MHz is used as the middle frequency. The transmission rate or bit rate of the information to be transferred is 16,384 bits per second and is modulated according to the Manchester coding. The advantage of Manchester coding is the increased transmission reliability. With this coding, a change in the plus edge from 0 to 1 or vice versa is performed in the center of each information bit. So the maximum transmission power here is 25 milliwatts. The radio transmission interval of each device, also called duty cycle, is 1%. Maximum transmission during of 0.6 seconds per minute. Thanks to the fixed transmission time, it is ensured that there are no individual continuous transmitters, and therefore no continuous interference signal exists that can block the radio channel. So, how about the multi-channel solution? Single channel solution that we talk about it, single channel radio communication can be distributed by other RF systems in the same or neighboring frequency band. In order to counter such a disturbance, there are, besides KNX radio devices with only one channel, KNX RF multi-channel, which can transmit their information over several channels, or exists. This solution dispose of several fast and slow channels. So it includes fast channel and a slow channel. Maybe in an exam they are going to ask you questions from here. The device can transfer from one occupied channel to one or more further channels. Okay, where we use fast channel? The fast channels are intended for applications such as lighting control, shutter control, which are directly controlled by human beings, and a slow channel are intended for devices which do not have to be in receiving mode continuously. For example, the HVAC control devices. Okay, HVAC control devices, for example, each 30 minutes provide the control value. In this picture, you can see the KNX RF multi-channel differences and allocated frequency. Okay, you can see the fast channel 1, the frequency between 868 and 868.6, the amplitude, you can see it, and fast channel 2, slow channel, and the combination of slow channels. Notice that KNX RF also checks whether a radio transmission is already ongoing before starting an own transmission. You remember that in the TP we have something similar to these facts. In this way, the number of possible collisions is considerably reduced. So we have the protocol to avoid the collision even in the wireless technology. The next important thing is KNX RF in general natively supports long frames. This is necessary to be able to support the KNX secure application layer used for security application, which can also be used by other KNX media. This allows authentication and encryption. In this way, the media coupler does not constitute the weak point in the security concepts. As such, KNX RF devices can use for applications such as metering, access control, fire alarm. You can see in the market nowadays that most of the KNX RF coupler support KNX Secure. On unidirectional devices send a telegram immediately if required. In a case of collision, the telegram has to be sent again due to the duty cycle of 1%. It is nearly excluded the collision occur. Bidirectional devices check whether the radio channel is free before sending a telegram. If a channel is occupied, the device waits until the radio channel is free and then send the telegram. This is for bus access. KNX RF devices are available in a flush-mounted, surface-mounted, and built-in version. The flush-mount devices mostly consist of equipment for switching or dimming lights, for controlling shutter drive or main equipment on which push button for operation are clipped on. The RF communication part can then be integrated in the mounting surface or in the device itself. For example, in KNX L snare devices, you can see the flush mount devices that you can put it in into the flush mount housing behind the keypad as an actuator with input, for example. The flush mount devices mostly consist of equipment for switching or dimming light, for controlling shutter drives or main equipment on which push button for operation are clipped on. The RF communication part can then be integrated into the mounted surface in the device itself. I mentioned that. As a surface mounted or built-in version, various sensors, actuators, or combined devices are available, which can be mounted, glued, or built into various locations and surfaces. In case of KNX RF component, the classical separation between bus coupling unit, application module, and loadable application software in most cases does no longer exist. They are complete devices. So when you have some KNX RF devices, you cannot separate it to different parts. You remember the bus chapter. All of them are in the same one device. They are complete devices in which the application software is preloaded in case of E-mode devices or loaded by ETS in case of S-mode devices. So here also we have the E-mode and S-mode devices. According to their function and application, the devices are designed as a unidirectional or bidirectional radio transmission. So it is a one-way or two-way transmission. Only send or send and receive data. Okay, unidirectional devices can either only send or only receive. Only sending devices are mainly battery-operated sensors or detectors such as handheld or wall-mounted transmitter, binary inputs, and door-window contacts. For door-window contacts, for example, you can see the wireless from the Siemens. Or for sensors, for example, you can check the I think MDT devices, maybe they have it. Bidirectional devices can both send and receive. They can sensor actuators at the same time. For sensor actuators, you can check the Elsner Electronic or Teben from Germany for this product. The KNX RF repeater is also a bidirectional device which takes over the automatic routing of RF telegrams in order to increase the RF coverage of an installation. So remember that I already mentioned to using repeater. If you have a long distance or there are lots of disturbances in your building, this can take the form of a standalone unit in wide variety of models, or it can be functionality integrated in a bidirectional actuators. Media couplers are used to connect KNX RF to TP. So it is interesting. To connect KNX TP to the RF, you should use the coupling. Okay, the devices in KNX installation using radio transmission are not subject to any type of hierarchical arrangement. They can practically be installed in any location, and if within radio range, each sensor can communicate with each actuator. As a part of the telegram, each KNX E-mode RF device sends therefore its serial number as a device identifier. KNX RF S-mode devices sends their domain address as a device identifier. Only the receiver touched in or linked to the transmitter or from part of the same domain will evaluate its telegram. In addition to the necessary separation from adjacent KNX radio installations, the range of the radio signals in building is also limited by structural conditions such as walls, ceiling, and furniture. So if there are some disturbances, it affects the signal transmission. The range can, however, be extended with up to 2 KNX RF repeaters, so that radio signals can also be transferred over several floors. Okay, combination of transmission media. One of the big advantages of KNX is the possibility to use different transmission media, TP, RF, IP, in one system. Therefore, a KNX system can only consist of pure KNX RF devices, but can also be combination of KNX RF with other media like KNX twisted pair. Okay, so here it can be used as a pure KNX RF or in combination with TP when you use media coupler. So in Elsner Electronic, the media coupler is this one, KNX RF L3TP media coupler. Okay. The media coupler can be additionally used as a repeater in order to increase the radio range. So it can be used as a repeater also. It depends on the type of the media coupler, how it is defined, which telegrams shall be transferred. This can be made in two different ways, only via ETS. For KNX RF S-mode comparable with the function of line coupler, you can see the media coupler as a line coupler. With ETS and via the media coupler, TP and RF, in this case RF E-mode devices which are to be connected are taught into the media coupler via E-mode. The necessary bus specific information is planned in ETS and then downloaded into the media coupler. Okay, about the commissioning. After installation of a KNX RF system, the tests applicable for low voltage installation must be conducted. Commission and programming the functionality in E-mode devices. So first of all, we talk about E-mode. The commissioning of a KNX RF system, it means the connection or teaching of the radio transmitter and receiver can easily be carried out. Usually this is made via the dip switch or push button action in E-mode after the mounting of the device or by the ETS. Both the actuator and associated sensor are put into commission mode and devices are taught in via the sending of a connection telegram. For example, here we want to make a link between the remote and the keypad, I think. So first of all, configure mode of transmitting and receiving. For example, here in this device, in this remote, we briefly press the configure button on the transmitter. The configure LED of the transmitter and all receiver within the radio range light up. Briefly press the push button on the transmitter, which should activate the function. The configuration LED on the transmission flashes. Transmitter and receiver are configured in configure mode. Two set of function of receiver. Briefly, in this device, briefly press FCT button on the receiver until the desired function is displayed. To confirm, hold the FCT button pressed longer than 2 seconds. Finish the configuration. Briefly press the CFG or configuration button on the transmitter again. The configuration LED on the transmission and all receivers go up. So it is really easy between the sensor and actuator. For example, you can press some button, start to flashes, press the button in actuator, and they are learned to each other. It's very easy. So in RF, You have the keypad with actuator inside, you have the keypad with actuator inside, and you have the remote control. So wirelessly you can communicate with these one to control it, or even if you provide some special scenario, you can communicate between these two keypad, include the actuators. And commissioning and programming the functionality in RF S-mode devices with the ETSUs. In case of commissioning KNX RF S-mode devices, the procedure is to large extent similar to that of the S-mode devices. Each RF line get a unique domain address. Remember about the domain address. The purpose of the domain address is to avoid interference between adjacent KNX RF lines. Therefore, each KNX RF gets an own domain address. Also here in KNX RF, the data interface is available for configuration and commissioning of the KNX RF S-mode devices directly from the PC. Here, KNX RF data interface. Functional test and test report for RF E-mode devices. Okay, the book said about something about the test. In addition to general check of the installation, the functional test of the entire installation must be carried out. All the function and taught-in or configure radio connections between the sensors and actuators must be checked. The sensor must be triggered or pressed, and the correspondence reactions of the actuator must be observed. For warranty reasons, the correct functioning of the installation must be documented and recorded in a test or acceptance report. As the combination between E-mode sensor and E-mode actuators can be changed very easily, and the installation could no longer correspond to the originally ordered version, it is recommended to record the configuration list. So in E-mode devices, maybe somebody can change it or change it in future. So you should record the configuration in a list, and whenever you want, you can refer to that. I hope you enjoy. The company who provides the KNX RF devices, it's Elsner, it's the Devon, MDT, Muller, and some other companies not in my mind. They are producing these products in KNX RF, S-mode and E-mode devices. Also, many companies provide the products that we do not need battery in sensor side, called energy harvesting, and I think there is a nice feature for KNX RF devices in we can see it. Thank you so much for listening to me. I hope this lecture will be fine for you to solve the problem in basic exam. Have a nice day. Thank you. Bye bye.